How's it going? How are you all? My name's Kevin.
Hi, Kevin.
Thank you, thank you. I'm not good at presentations in general, so one thing I do like is questions. So feel free to ask me any questions. And I don't have a lot of slides prepared, but I have enough to kind of like hopefully prompt interesting conversations. So specifically, what I'm giving this talk on is my work last year on the LLaMa 2 project, which was the follow-on to the first one of Meta's first like very successful large language models, LLaMa 1. And so we focused one on doing a little better, larger scale or better pre-training. And then also more importantly, the part I worked or the part I know the most about is the chat side, making it more helpful and safe and stuff. Yes, go ahead.
Okay, so like when LLaMa 1's like stuff was leaked with Fortnite,
Yeah.
like what went down? Like was it like the most did the whole Facebook headquarters like go in like flames like with like red alarm signals everywhere? What happened?
No. It was all good. I think a lot of that stuff is we have to be very careful because there's safety considerations. And so we want to be like, okay, this is good for research use, but we're not ready to say like the general public should use this. And so we try to do due diligence to do that, but it's not necessarily, like the end of the world. And people know that we weren't officially stamping this as good to use yet.
Did you guys patch the dude that leaked it?
No, we don't really care. I mean, we care, but that's like once again, we're trying to do due diligence, not necessarily stop every possible leak.
Question.
Yeah, go ahead.
Are you legally required to have that stamp?
I'm not a lawyer. I haven't answered this question. Let's see. So just a tiny bit of background. I've done a bunch of random stuff from like signal processing.
CPE.
Computer engineering was I wanted to learn computers from the ground up, so started with CPE, started EE, then CPE, and then now I do just Python code. So kind of uses from Sacramento. So I started working in like robotics, signal processing, and then most recently I've gotten into the reinforcement learning large language space. Let's see. So actually, quick question. Did I get this ordering right? Yes. Do you all know what a language or what is a language model? Curious, what you guys think. Okay. See. So this is one technical definition of it. And it's just saying, given past words, can we predict literally the next word? And which is surprising, or actually, yeah, which is surprising to me. It's literally just predict one word given all past words. This is like how we actually use it in a larger network where we have some sort of, in this case, transformer in the middle. Using something as simple as cross entropy, literally given a word like, let's take a sentence, so long and thanks for at every single word. So you're trying to predict the next one, long in this case, or after long, you're trying to predict and. And at every point, you have some sort of probability distribution over all future all tokens for that word. Okay, so that's a language model. I think they were invented in the 50s. Does anyone know, or what to everyone is a large language model?
Is it supposed to work with a lot more inputs and a lot more tokens to provide you with a better answer?
Yes. Actually, why is modeling language interesting? I'm actually curious why.
We can do my homework.
Very good. That surprised, I think, a lot of people that it actually is effective. But yeah, so large language models literally just take a language model, that simple idea, scale it up way past when we should have. So like OpenAI did this and everyone thought this was a waste of money. They shocked everyone with GPT-3 and it performed way better than anyone expected. But really, in general, there's like, I consider it's four components. One, data. So tokens are roughly words. More modern networks are trained on roughly 1 trillion words. This is often just download the internet and then train with that. The other is compute. For a full pre-train from scratch, it takes a significant amount of compute on the order of 1,000 GPUs for the order of 1 month. Larger models obviously take longer, but that's like a median model today. Cool thing is you can do a lot of some fine tuning. You don't have to pre-train. So there's a lot of cool experiments you can do without needing to spend that much money. Okay, the other thing is the model class. Transformer is a term I'm sure you've all heard. It is interesting. Actually, I'm curious, do you guys know why we use transformers?
Because of self-attention. It's the way that it looks at the information that makes a difference.
Okay. I mean, that is actually, that's one of its like selling points, but I have a very boring view of it. It's just that it scales well. So it scales well. It can, if you take an LSTM, an older model, and you use larger and larger dimensions, eventually you can't get it to optimize, but with Transformer you can. The other thing transformers are good at is they use something called teacher forcing. So you can take a whole sentence and enforce it all at once. Whereas with an LSTM, you have to literally roll it out through time. So it can take a long time to optimize. The other thing is the objective function, the language model objectives function. Also, teacher forcing is this sort of like magic thing that people don't often talk about, but I think it's critical. So, as I alluded to, transformers invented by Google, I believe. Attention is all you need. This is like the moniker that got myself included. I was, oh, attention is the thing. And really, I don't think attention wasn't the key thing, although it's very helpful. They scale well. GPT-2, once again, OpenAI took this concept and they spent at the time a lot of money on this. And we were like, why are you doing this? But it worked surprisingly well. This is the first time they sort of withheld their model. They were like, fake news might be an issue here. It started to generate paragraphs that were like kind of plausible, but not great. GPT-3 was once again just shocking to me because they spent now like 100 times the amount of money with no like obvious payoff. However, it was incredible. They were able to take new tasks and give it 4 or 5 examples, and it solved things that they'd never programmed it to do, stuff that wasn't on the internet, which once again was shocking but amazing. So now GPT-3. It actually has been online since 2020, but now people roughly know about it because of ChatGPT, which happened over the intervening 2 years, basically because of this idea of using reinforcement learning on top of that core base model. And so those 2 things are sort of the magic behind ChatGPT. But
I thought GPT was the same as RL chat.
it is, roughly speaking. Yeah. Yeah, it's not, the plus doesn't make sense. There should be like parentheses. Yeah, so GPT is basically GPT-3 plus this extra RL phase. Yeah. Any other questions? Okay. So another sort of thing that came out around the same time was Google had this paper called Chinchilla, which showed that there's kind of, it's actually like 3 scales or 3 axes, but 2 let's just talk about, which is data and parameters. And they showed that if we, instead of increasing parameters, we can increase compute and data itself and get better performance with a smaller model. And so the first LLaMa LLaMa 1 was based on this principle. Let's scale up to 3 to 4 times the number of tokens in compute to get higher performance with a much smaller model that might be able to be used in production rather than something that's so large we can't actually use. Let's see. And then ChatGPT was originally supposed to be a test for safety, and it blew up quite a bit. And now people use it to do their homework. So yeah. So there's a little backstory for our team. So ChatGPT came out. That's when I actually joined the LLaMa teams. They were like, as an RL researcher, they wanted us to try to replicate ChatGPT using the LLaMa 1 model. So that happened. That's November. I joined the team around January. So we're now working super hard to try to beat ChatGPT. At the same time, GPT-4 comes out, and we're like, it literally like blew every metric out of the water. They trained it with 100x the compute, and so we knew we'd be behind GPT-4, but we were still, the goal was just to replicate GPT 3.5. This is a little bit too much detail, but this is sort of our progress, kind of trying to catch up. Let's see. Yeah, so the LLaMa 2, with the LLaMa release, it was kind of fun. A lot of papers, research labs, schools have taken it and basically done a lot of fun paper follow-up work on it. So now we are learning so much from everyone who's using it. So I read papers from people all the time, and I use it whenever I can. Go ahead.
Are these slides like on Facebook or are these like?
Both. You'll notice weird style changes, and that's probably because it's.
So pictures on all of this?
Oh yeah, it's fine. It's all public. Yep, this is all public information. Let's see. Okay, so I'll get to the part that I mostly worked on, which is, or I guess this is the full overview of pre-training, fine-tuning with supervised data, and then reinforcement learning. This is sort of here's the overview. So you have first stage, pre-train, use all that compute, download the internet. Second stage, fine tuning, given high quality question answer pairs, can we have the model learn to emulate that? And then the RL and the human feedback comes from we actually just test it, take its answer, and then we ask labelers to say A is better than B or B is better than A. Just a couple of random details on the size of the model. We trained a number of classes of models, which is really nice. I'll often do experiments with the 7B model that fits on one GPU, and then I'll make sure something works there, and then I'll scale it up to the largest one. So this is very practically very useful. We trained it on 2 trillion tokens. It has a significant amount of human preference labels, which increases its helpfulness, its safety, and hopefully its usefulness. Yeah, real quick pause. Any questions? I can happy to answer anything.
Can I go back to the previous slide? What
Yeah.
is it between context length and like what we think of as an input for like?
It's basically the same.
Okay.
Yep. So it's basically you have up to it. The network has seen during training sentences or documents as long as 4,000 tokens long.
Okay.
It can be extended, but that's how it's trained.
Speaking of context, length and stuff, what do y'all think of attention sinks?
I don't know what that is.
Well, the paper that was like blowing everyone's brains out.
I should read it. I don't know. Do you recommend it?
Yeah, but it's kind of clickbait.
Okay. So, okay, perfect. I'll check it out. Let's see. Okay, so just this is kind of a cool graph. You can see here those 4 models training. You can see these are the perplexity curves, which is related to the loss function. And you can see it's training from 0 to 2,000 tokens. Each model gets progressively lower in complexity, which has a significant difference in the final quality of the model on almost every single task.
Sorry, can you define complexity for us?
What is perplexity? I know it as taking the exponent of the loss function, but it's related to, actually, does anyone here know what perplexity is?
Enough perplexity.ai.
That is a great search engine. Yeah, so it's related to the entropy or the ability of the model to predict the next word. So it's a summary statistic of that distribution relative to the actual ground truth.
Is it the exponent is because of the whole like P of T times T of T minus 1 times like.
It's related to that. The math isn't terribly complicated. It's a Wikipedia way, but I don't know it offhand. So.
That's basically the loss.
It is related to the loss very, very simply. So I should say NLP, natural language processing, has like tons of statistics basis. My coming from like a robotics background, a lot of this stuff was new to me. So I'm like trying to come up to speed as fast as possible. But even this is a good example where some of the like obvious stuff to someone who's been in this field, I have to still look it up on Wikipedia. So yeah, LLaMa 2 was trained longer, got better results with the same model size. So continued scaling loss. Here's a bunch of random metrics. The ones that, like, for example, I kind of care about, and a lot of people seem to, is this thing called MMLU, which covers a wide variety of subjects. Just showing that this LLaMa, it's basically a comparison against LLaMa 1, LLaMa 2. More compute paid off. Okay, so that's the pre-training stage. The part that I was most involved with is reinforcement learning from human feedback, RLHF. To get the process started, we asked our annotators to write a prompt. So in this case, write a poem to help me remember first 10 elements. They then hand wrote this prompt. So this is very expensive data to write. 1, they're coming up with novel prompts. 2, they're coming up with like high quality answers. But
How did you like by coming up with the prompts and the data, how did you make it so it wasn't as biased with the prompts? Because that like there's only what like quality or something, and then it's like coming up with a distribution of that. Like,
Yeah.
I
So
find that's a headache.
we use Scale and Surge for our annotation companies. So they have a lot of labelers, and so it's sourced across all of them. And then I don't know if you guys have heard of like sentence embeddings, but it's a way of taking a sentence or a paragraph, turning it into a vector, and you can do things like clustering to remove prompts that are similar. So that kind of helps with that distribution.
So is there like some benefit like synthetic generation of prompts?
Yeah, it's great.
I would You guys tried it, like automates it, I guess.
It works as well as it works, but then it also, having humans in the loop is always great. And like, this is where something like ChatGPT has a big advantage. They literally have 100 million active users monthly, so they can just scrape their prompt, like with questions.
So is there like a reduced audience that it can answer, or do you just like need to evaluate? You know, just discard.
I'd say both. You get an amplifying effect, but you need like a starting point with like human data. But yes, it's a good technique, very good. So yeah, the main takeaway from this is it's very expensive. It needs to be high quality, so you need domain experts, and then also it needs to, they have to write out every word by hand. Okay, so that was expensive. So okay, SFT, supervised fine tuning, reinforcement learning. What we do on top of that, why do we do it? Mainly, so I kind of skipped over this, and I should add a slide for this. But we take that SFT data and we train the model with the same cross entropy loss to try to predict whatever the human labeler annotator wrote. It does a fairly good job, but if you think about it, it's only been trained to predict the next word. And so it's shocking that it ever can predict a whole sentence or paragraph, but it ends up kind of doing a good job. However, what RL gives you the ability is you ask it to generate the whole sentence. You can look at it and then say, given this entire sentence, I'm going to say good or bad. And as you can imagine, if like I stop half, is that a good sentence? You guys don't know, but if I finish it, you can be like, okay, that's good. So that's all this is doing, is it rolls it out. Then another network, which we train with a preference label, A is better than B or B is better than A. It then judges saying, A is better. We then reinforce A and then downplay B. Yes.
What are sentences that are very long or contain multiple clauses?
So this is where it gets really messy. There's actually a number of answers to that. One, first version, you don't worry about it. You just generate the whole paragraph and have it judge an entire paragraph. So that's what we do for this project. Follow-on work, and like what we're doing now, is we break it down into parts, steps or sentences, and you judge each one. And then it gets better if you do that.
What about like, so sentences, words, paragraphs, whatever, they're all defined in relation to each other.
Mhm.
So how do you guys capture those relationships?
Language models do a good job of that. That's what's surprising. So they already
No,
have
but
captured.
For Harley, is that?
But so we use that same language model as both a reward model and a generation model. That's the magic. We just don't have to like try that hard because it already has done such a good job. We literally can just ask it, is this a good sentence? Yes, no. And then if the annotator says yes, we say yes. We force it to say yes. And if they say no, we say no. But you can imagine you can make that better if you say like, is the grammar of this good? Is the spelling good? Is the structure good? You can ask all these questions and reinforce all those signals. But that was not this work. That was follow on. Yeah, so the key here is it looks back rather than just having to predict the next word. The other one, it just works. So we don't have to get into this, but so this is the math behind reinforcement learning. Okay, this was the paper from, this is InstructGPT. This blew my mind. So the lines here are confusing, but okay, SFT. So this green line here, we take the largest model at the time, 175B. It wins against itself 50%. Okay, that makes sense. But if you take PPO, this RL model, and you take their smallest model, 1.3 billion, that model beats this model 55% of it, or 52% of the time. So they were able to take a model that cost them roughly 100 times less and get it to perform as the one that costs that much. So you can imagine if you take that fancy one, it also gets this amplifying effect, and it's up here at like 65%. So that's the pragmatic argument. So I kind of skipped over this a little bit, but yeah, the reward model is trained from binary preferences. This gets to the cost. It is way cheaper to gather A is better than B than it is fully written paragraphs. So that's the human feedback part. So from like just a cost and practical point of view, this is a very good process as well. This is a somewhat interesting graph showing we started here. This is our version of that InstructGPT result. We started with 10% preferred. And then by the time it had finished the RL process, it was 60% preferred and hopeless. Oh yeah, harmless, like safety. And then 68% preferred from like a helpfulness perspective. And this is a fun like graph just showing this is distribution of helpfulness scores, 0 being not helpful, 1 being helpful. And as it progresses, it shifts that distribution to the right over many iterations. Go ahead.
I just wonder, if we like, people do that, do you like regularize for a human giving feedback? And then,
Yeah, so it's a good question. We have some like quality filters that we apply, but not enough. I think there's a lot of room to take. So like right now we have all this preference data and we're starting to go back and like remove low quality data and that's boosting things. Yep. Yep, smaller ones that are like custom trained to do a specific thing. But that's a very important thing that we're just starting to like tap into. And I'm sure other companies are doing have gotten farther than we have. Yeah, so in the end, we were able to match ChatGPT 3.5 performance. We're nowhere close to GPT-4, and that's what we're working on next. So yeah, that's my talk. Yeah. Any questions? Happy to answer. But yeah, that's
with the instruct, you can see that I got a very small model to. Okay.
so that idea of having one model that's doing generations, you generate it, it makes a bunch of mistakes. Then you have this reward model, which is trained just to say good or bad. It looks at that and it says, oh, that's bad, this is good. You have it do that on a large batch of data, and then you do a gradient update, and that small one learns, you can think of it as learning what it's bad at, and it learns to avoid things that it's bad at, rather than just stumbling into them and getting worse.
After being trained llama, and like after the like new features, which are like new new tricks that you can get added to technology, like make sure experts are like pretty popular right now, so like drugs and all that. So after the like features get added.
So anything in pre-training is going to take a lot longer to get added because months of compute on thousands of GPUs. But things like fine tuning, we try frequently, and if they improve things, we keep it. If not, we ignore it. Yeah.
So Meta recently said they're going all in on open source AI. Why is that the route they've chosen? Like, how do you guys kind of plan to profit off that as well?
So I mean, I'm not gonna like go too much into the politics or the policies of that, but I'll just say like practically speaking, we've benefited from open source using our work, finding cool stuff, and then we get to leverage it as well. So that's one. The other is like it's training up more people to understand how to use them, and if there's good people, we hire them. So I think that's my angle. That's what I'll say about it.
This is a signals question. Can you explain Laplace transforms from a conceptual perspective?
It's been too long. I have to like update my short-term memory with a YouTube video, and then I could, but not offhand. Sorry. Okay.
Sorry, did you explain, how do you train the, like approval reward model? How do you trust that it's saying yes to things that you want to say yes to?
So we kind of treat that as a supervised learning problem. We'll take the data set of question, answer. So it's question, answer, and then we have them pick A or B. We'll just split that into 80%, 20%, and then improve that held out set or test that held out set. Yes.
So the reason you're using like another language model as a reward model is because it's like, you're not trying to spend all day saying yes or no to a, yeah, like, so you're just like trying to get another model to communicate to another model.
Yep.
So the other model like gets the gist in it, is able to reproduce that.
And you can think of a good example is that small model makes, let's say, some easy spelling mistake constantly. It's going to be trivial for that larger reward model to learn to say, no, that's bad spelling. So, and then we can use that, like, for example, we'll run 200 iterations with a batch size of 512. So that's like 100,000. So during training, it will ask that reward model 100,000 times for a yes, no. So that would be too expensive for human labels. And that's just one experiment times, 50 to 100 experiments.
Okay, so that's like a method of semi-supervised.
Yeah, it's like an amplification method. I mean, this is like model-based RL where you have a reward model. That's where it came from.
What I thought model-based RL was like where you have the like the transition function and like it's trying to predict the next state of the world.
Yeah, so I mean, in some sense, the policy is doing that. It's its own transition function. But then also the part that we're using from that is more the reward model itself. Which is one of the aspects you learn. You can learn a transition model, a reward model, all kinds of models. In this case, the RM is the most important.
Yes, I should have used long instead of ChatGPT, that's what taught me was wrong.
Oh, ours is also wrong a lot of times. Yes.
You mentioned that ChatGPT is super lucky to have like 100 million users feedback, user feedback.
Yeah.
Is that part of the rationale of like, Meta making their AI models open source and then also like adding them to Instagram and, or, first Snapchat, now Instagram?
Yeah, so the production, so we're on the research side. We work closely with our production collaborators, and they get access to production data. We don't. We're like isolated to open source data. So they're probably going to benefit from that. The problem is, like, I keep asking, like, I would rather us run like a chat GPT like at a loss just for our own sake, but we don't. So yeah.
What's your favorite MLOps tool?
What I actually use. My favorite tool is the JSON-L file format. I just do my own MLOps.
But, his, my favorite one is DVC.
Never use
It
it.
just like automates it all.
I think WandB is a pretty popular one.
I like Facebook's MLOps for their internal tooling. What sort of features do they have that they like?
A lot. I'm not in the like internal systems, but I get occasional glimpses and it's very well built out, like very, very advanced.
Do you speak about that or?
I don't know enough, yeah, about it. So, and there's some published works on some of the internal stuff they built. Like I think there's some feature stores that we talked about. And, yeah, but I don't know enough to talk tell anything about it.
What's the most interesting research?
So I'm very, so having worked on this, I noticed that like we could make this actually. So this upper right graph shows that RMH1, so that's the reward model helpfulness 1 model score going up. And you can see even that blue line, how it just shot up there. Looks like, oh, it's super helpful now. That's not true. It would end up just like using emojis and smile and like saying, I'm sorry, I'm sorry, I'm sorry. And that tricked the reward model to like give it a lot of thumb ups. And so I tried a lot of things that make allow us to optimize further without having that sort of exploiting behavior happening, but it kept happening. So I now am kind of motivated with more like grounded problems like math and science kind of problems where there is like a ground truth answer, and then you can optimize a lot longer. So that's kind of what
I'm using like things in like kind of separate things as reinforcement.
so like you could imagine if you write code and run it, you can take, did it compile? Was it like valid syntax? How fast was it? Those are all like signals you could use. As just an example. Yeah.
Is that exploiting the principle happening in production right now? I was asking the Instagram and Meta AI, and it kept saying, we'll use it like 3 times in like a single sentence.
That sounds like, yeah, it sounds like you found some of these issues. Yes. There's tons of these issues. And I think the way that there's like a whack-a-mole version of this, which is just keep labeling data, which is, we're doing that. But we're then on the research side, we're trying to like come up with a more principled approach. It's just hard. It takes time, but yeah.
Can I ask, this work that you're doing is really fascinating, and that's like where I'm hoping to be in 10 years. So can I ask how you positioned yourself to like work on this? And do you have any recommendations for us as undergrads to like set ourselves up for that?
Yeah. So I have a Bachelor of Science degree only. I would recommend considering master's or PhD if you're interested in this, because I've essentially like gotten here by like spending way too much time working towards this goal, because I kind of had this goal in my head, but I didn't just go to school for it. So I think I'd recommend like upper level classes.
Yeah.
I mean, it's doable. It's just a long time.
Thank you.
Yeah. Good.
So like with Meta AI research and like all these like big tech or whatever, or just companies in general, you guys are all like working on a lot of LLMs and stuff like that. But like, have you ever, I don't know, like just had some random idea, woke up or something, had a random idea and just wanted to do it just cause? And then like, how does that work? Are you guys like forced by investors or something to do LLMs, or like when you just decide, okay, what to work on? like, because research is research, so. Someone can just wake up one day, have some crazy idea, and
Yeah.
then it turns out to be like facts, so like.
Yeah, so I think there's like different kinds of research. We're like more of the somewhat de-risked research, so it's like truly like green field, like very high risk, high reward stuff. Some fair research does invest in some of that, but more and more, like our team specifically is like, let's take the stuff that's been de-risked a lot, and now let's just pour lots of resources into it, both time and like compute, or human time and compute. But yeah, both are very important, and I think we look a lot to like academia and other groups for inspiration for the like super high risk, high reward stuff.
Like things you do as an undergrad to like get you worried about, like, do you do a lot of papers, do you implement stuff on the papers?
I highly recommend implementing stuff from scratch.
Okay.
Like when I was learning this stuff, I was like writing, like I wrote a transformer that ran on like my CPU, like trained in like 5 minutes, and it was terrible, but it taught me everything. So definitely don't worry about, I mean, there's 2 ways of doing it. You can either do the experimental route or the like write it from scratch route. I recommend a little bit of both actually, but definitely from scratch as well. Or up in the back, yeah.
Oh, okay. I see that, you're part of the research element of this, and I see that there's also Meta's reaching out to people to do research on this subject. I'm curious, how much engagement has there been there, do you know?
I mean, in terms of like, I think the number, I mean, that was kind of this slide. It's not, this is like an older version too, but there's been a lot of papers and follow-on work from this, although now, like actually the LLaMa, it's half the LLaMa 1 team left and started a company called Mistral, and they're very good, very, very good. And they're getting a lot of their work is now getting, people are using it. So I think this is now just a very popular space. So more and more, the open source ecosystem is just going to get better and better, and it's going to branch off even further. Okay.
You speak on the Chinese data section, it seems like there's a considerable amount of like Chinese products with papers.
Yeah, so there's this like China, like, so I think they've like scanned a lot of their books and have access to like very high quality, huge amounts of high quality data. And that can be like a major boost of performance. So there's a hunch that like their models, especially since it seems like LLMs can kind of blend languages, not perfectly, but somewhat. So even like non-Chinese tasks might get better, not just Chinese ones, because it's just like so much high quality data. So, but I haven't done any experiments with that.
What's your opinion about like, writing like space models?
It's awesome. I mean, that's where that's like a super high risk idea that like I will say this, if you have like a architecture idea like that to pull off, it's so hard to like, because to get people to like take that seriously, I think they had to scale it up to like at least the billion scale before anyone would pay attention. And very, very good researchers, lots and lots of money. And so it finally happened, but it's very hard. However, it's awesome because now it's like another model that might like supplant the transformer, which is cool.
Okay, so in 6 years, I want to be at the giga high risk level, like the highest risk.
Okay.
The highest in the world risk.
Okay.
Like where you're just like implementing crazy stuff daily.
Okay.
Like stuff that people are like, why are you doing this?
Mhm.
I know it's a little bit less traditional than like, the standard LLM stuff or whatever, but like, I mean, it could be LLM, but like, what do you recommend in that regard? Because like I don't really see many people in that area, and those who are those who are at the very top, and when you like message them or whatever, like they're not gonna respond because like they're like legends.
Yeah, I mean, I honestly think you need to go to institutions that are doing like more pure science and like frontier science, and that, because I'm just guessing. I don't feel like I have enough qualifications to talk on this too much, but like any sort of corporation that's going to fund sort of research, it's not like truly frontier research. It's like, I mean, I'm guessing most of it's going to be more like we potentially could make a lot of money with this, and so it's going to be a little bit more limited in scope.
Okay, but what if you own the corporation?
There you go. I recommend that. That's what you should do. That actually is, I think I've heard of people who like got into crypto just to like do AI research, and then they made enough money and were able to self-fund. So yeah, it's great. Go ahead.
How do you avoid burnout in the valley? It is a very.
I live in slow. I work remote. That's how.
Oh,
Yeah.
So I was gonna ask you work-life balance stuff, but it seems like you got it figured out. What do you do outside of work?
I have 5 kids, so that's what I do outside of work. I have a family.
There we go.
Yeah.
I like a full-time employee, like, how do you spend time to like stay up to date with trends?
So that I'm super thankful for. I'm able to do that during the day. So in the past, I literally would work like my normal job and then also self-study a lot on the side. And now I pretty much can self-study during the day and I just allocate time for it.
So then, since you mentioned that you self-study during the day, as part of your job, like, what does the structure of your job look like? Because you mentioned like you're a research engineer,
Mhm.
so doing engineering. So
Yep.
how does engineering tie into your exploration of like those trends?
Yeah, so
Does it hinder you or?
it helps and hinders. Like in the last year, I can think of half the year was helped by and half was hindered. The part that was helped is, so for example, to do this RLHF stuff, we didn't have any of the infrastructure needed to rapidly switch between generating and train and like do gradient descent. And so I had to write that, but because of the engineering background, I knew how rough and how long that would take. I could like plan and I was like, okay, this will only take, let's say, a month. And so therefore it's doable versus like this could take anywhere from 1 month to 12 months. Therefore, I don't know, therefore I'll try something else. So knowing that, having an engineering background really helped. But then like the second half of the year, I had a ton of research ideas that I put on hold that I didn't have to, but I did just by just maintaining stuff that like, so then I didn't make any research progress, but I was just like squashing bugs essentially. So that's where I'm constantly learning of like how much to allocate to, and I don't have a good answer for that, but that's just it's both a benefit and a hindrance.
You mentioned a bachelor's, like, what did you do as a bachelor's student to like, to get you into like your research?
Okay, my biggest trick is I joined, it's like Google, I joined as a site reliability engineer, software engineer position. And then once I was there for a year, and then I switched to a research team.
How do you do that?
Like,
So
a lot of big companies let you do that. Not all, but some. So I did the same thing at Northrop, same thing at Google. And then Meta was the first company I joined just straight up as a researcher.
like usually when they hire, they're like hired for a very specific role. Like they're like looking for something very specific.
Yeah.
And I don't think they like hired to like, learn, they just like want the skills straight off the bat.
Yeah, I think this is where like bigger tech companies have this like idea of like a SWE is a SWE. And so if you can get into a group that feels that way, then a lot of times you can do team transfers and you can get onto more researchy teams. I'm not, like I said, I would recommend just get a PhD, just do that and you'll skip all this. But if you want to do it the hard way, you can do it. It's just, it's a long time. Yeah.
As somebody who does research, do you have to apply for grants from Meta, or do they like have I guess that's more of a business specific question. But I'm just curious.
Yeah, so there's, we've changed our process. There's like FAIR used to be much more greenfield, high risk stuff, small, like 1 to 2 person papers. And then because of a lot of the success of this and needing to put a lot more money behind an experiment, now they've started to encourage us to go to like larger efforts and kind of like working on like, let's say 8 to 10 person teams versus like 1 to 2. So it's just changes. And then a lot of this is politics, as you can imagine, but it's not too bad. I have a lot of freedom and say just, but it's a give and take. Okay.
Out of the course of your career, what are the most valuable aspects of communication skills that you think are owed to you, I guess, and especially in like, I guess these companies?
I'm a terrible communicator, both writing and I'm terrible at it. So I'm not a good person to answer that. I don't know. I don't feel like I have a good answer. I think it's really, if you are a good communicator, like visualizer, writer, like you can, I think that's a superpower. I don't have it, and so that's definitely a bit of hindrance. But if you have that skill, it's very good. I highly recommend it.
2 questions. Which high school do you go to and what's your day to day?
I went to a preparatory academy that got shut down. Yeah, it was a part of a church. It's called Sacramento Preparatory Academy, and like my junior year it closed. So I had to like just graduate with chess beat, but yeah. High school. There was the other question.
What does your day-to-day look like?
I work, oh, so all my team is in Europe, so I get up super early and I work like until like 4, and then I go home and then hang out with the family. It's my day. And then the weekends I go to the beach, slow stuff. But
Do you, that Meta is like targeting like a personal AI like chatbot niche? Because I feel like they're taking a lot more consideration into like how it responds and like it's kind of like we know.
yeah, I think one of the differentiators of Meta is we care about the social aspect of things more than, let's say, Google or AI. And so I imagine that's going to be a big focus, but I don't have any like we're pretty much just on the like try to get the best general purpose LLM, and then product teams are much more like product research teams are much more focused on that style thing, but I don't really know what exactly they're up to.
What do you think about Mamba, the state space model? That's like,
I haven't had a chance to play with it, but it seems very promising.
What kind of prep work goes into the projects that you work on?
Let's see. So one of the things is because it's such a heavy compute requirement, we'll have like a guess of, let's say we have a new model, and let's say it's a pre-training experiment. We will, roughly speaking, do this like risk reward estimate and cost. So like we'll be the risk kind of slash cost is kind of lumped together. So we'll say, okay, we want to do this this Mamba experiment. Okay, we think it's going to increase our base model by 5%. It's going to cost X number of compute, and we have these, like everyone else has their list of 10 things. So once a month, we'll like kind of get together, look at the top 10 ideas, kind of rank them by everyone's intuitions and that sort of estimate, and then we'll pick the top 5 to like actually run them compute wise. That's the main limitation. But yeah, sure.
I'm actually surprised about you implementing PhD right away. Especially that I was talking to someone who works at Google 4 weeks ago and said like he really regretted going for a PhD. He said master's was great, but
Oh yeah, maybe that's a good compromise. I think the grass is always going to be greener. So because I didn't go that route, I'm like, oh, maybe that's easier and better. But maybe it's not. So I always like to say that just to be I've heard that opinion quite a bit.
Yeah.
And from the Bay
Is that-
Tech, they always say that.
Yeah.
But I just want to like give the other.
what he told me is when you do the PhD, you skip the junior role, you go straight to the senior role.
Yeah.
But then you don't really have that many connections. You don't know the politics in the company.
Sure.
And I'm like, especially that you're like staff research engineer. Like if you waste 6 years of your life for that, not waste. Okay, if you use 6 years of your life in school,
Yeah.
You're not gonna have enough connections to get promoted.
That's what you do it too.
Oh, that's a good idea.
Yeah. No, I do ask around, get more advice. That's just one opinion.
Yeah.
Wonder if you give some advice in terms of if you want to like on these kind of models.
Yeah.
Specific, or like examples of like like it's like personality, how like responding to questions in a specific way.
Yeah.
Like is that simple, like kind of like transfer like trait based on data process, like would it be able to like catch on that kind of trend of like given this kind of prompt, you want this kind of expected behavior?
Yeah, so it'll learn so fast. The larger the model, the faster it learns. On the order of, let's just say 1,000 examples. So the easiest way, if you have an experiment you want to run, is you ask the largest model like to generate. So you come with 5 examples, and then you say, given this few shots, or given these 5 question answer pairs in the style I like, generate like 1,000 more. It will automatically generate 1,000. Then you fine tune with those 1,000. So you can essentially bootstrap your whole experiment from just 5 examples. Of course, you can do better if you come up with a real 1,000, but if you don't have time or money for that, you could still do quite good with just 5.
The repetition of the same prompts, or what do you mean by?
No. So like come up with 5 really good examples of what you're trying to learn. And maybe 5 is too low, maybe it's 10, maybe it's 20, but like come up with something that's very diverse and high quality of whatever you're trying to train or teach. Then you have a large language model, let's say GPT-4, just generate you 1,000 more examples.
Of bootstrap based.
Exactly. And now take those, fine tune whatever model you want and see how it does. And that is a great way to rapidly test something. And then of course you can always throw it away and like do it right, but that's a really good way to like go fast.
That's pretty ironic.
Oh, I know, it's so good. It works really well. Yeah.
So since you work with people in Europe, obviously you guys have like different backgrounds and stuff. So how do you guys work together as a cohesive unit? For example, like from what I found, usually in teams that I guess it works best when like one person is like the mastermind behind it all. But that doesn't really scale as well when it comes to like if as the projects become larger and everything like that. So how do you guys approximate the level where you're like almost having a hive mind?
Yeah, so we're always iterating, but what our current scheme, which I kind of like, is somebody has like an idea of, let's say, how to improve reasoning on math problems. And so like 2 or 3 of us will spin out for a couple months, completely isolated, don't have to do anything contributed back. If we have good results, we will then come back and fold it back into the main project. If not, we'll throw it away and pick another thing, or maybe just help out on the main, sort of like make everything better a little bit. So iterate that a lot.
This is like a. So you're basically like, there's a rendezvous point split, like that.
But it's a lot more organic and it's based on people's, like, what they're interested in. Some people want to do something super high risk, or in our medium risk area, something higher risk versus the lower risk stuff. And it just depends. And there's enough differences in like opinions and like preference of risk that it seems to cover our portfolio the way we'd like it to.
So you guys focus on, I guess. Like testing something out and, or maybe having some kind of proof of concept before, just having a full on complete discussion and judgment about it.
Yeah, that's huge. If you want to try something new, do that experiment of like generate 10,000 synthetic examples, train something tiny that like can train in like an hour, and then get some positive result, make 3 slides on it at the next team meeting, say, hey, look, I got a cool result. Could I spend a month on this?
Okay, so in that case, it would be a better approach to just experiment with something instead of sitting around yapping, basically, right?
Both are good. Both are good. But definitely in the end, having some small scale experiments does like win most arguments.
All right, we're approaching 2 o'clock. Should we do like 2 more questions and wrap this up?
Sounds good. Sounds good.
I think you kind of just gave a brief overview, but I was curious when you said like a team breaking off to try and improve math reasoning.
Yep.
What would that look like? What would that process look like? And how would you actually improve these?
Yeah, 2 super questions. Let's see. What does it look like? So a lot of times our breaking off is a little bit longer term. So it's more of like a quarter level commitment, so like 3 months. And normally there will be like a month of like, hey, I'm working on something else, but in like 20% of my time, I'll like prove this out, get some evidence of something, and then in the next quarter planning, I'll like present this and try to get like 3 or 4 people to work on this at least half time with me. So that's like practically how it's done. And then because we're research, we don't like, everyone wants to make like a big contribution. And so there's sort of like a self motivating. You don't want to pick something too risky for yourself. Otherwise, if you keep failing at these high risk things, your own career is impacted. Maybe not negatively, but not positively. So you always want to be on something like medium risk or high risk that works. And so we don't have to like enforce this very much. It just kind of like naturally happens. And then so for the math reasoning stuff, there's a ton of papers on like tree of thought and chain of like step-by-step reasoning. That's like probably the most obvious thing to work on. And that's a lot of what like our stuff is, this semi-obvious, but hopefully high reward stuff. Yeah. And
How much of a like research project process or research decision making process have you been able to like automate or make much more different?
so that's a really good question. I think that's some of the most important work, and I've done little bits of that, but not near enough. And I think those sorts of tools and automations about the research process itself are going to have huge dividends. And I think because LLMs are so good at doing such a broad variety of tasks, this is just going to happen more and more. So like the reward model is one example. You could scale that up to like a lot of things. Awesome. Thank you guys.
Well, thank you, Kevin. We really appreciate that.
Good.